A very good morning. Today, me and my friends are going to present about terminal velocity and Stokes' law. My friends consist of one Muhammad Shaifullah, Dinesh, Pritesh, Erwin, and Maverick. Dinesh being me. Okay. Next slide. Our presentation is going to consist of introduction and problem statement, which are going to be presented by Pritesh, methodology, which is going to be presented by Maverick, results in discussion, which are going to be presented by Saifullah, and conclusion, which will be presented by Erwin.
Hello, my name is Pritesh and I will be doing the introduction for our project. First of all, terminal velocity is the maximum velocity at which the drag force equals the driving force when an object which is falling due to the effect of gravity, or the drag force that increases with velocity. Secondly, a second part of our project is to explain Stokes' law. And Stokes' law basically is the drag force that is exerted on a spherical object with very small Reynolds number in a viscous fluid. Next. Now, the problem statement for our project is what is the significance of terminal velocity and Stokes' law to daily life and the world of physics? And also, how can we quantify these two important aspects of physics? The objectives of our project is to gain a better understanding of how terminal velocity and Stokes' law works, and to analyze the methods to implement these observations of these two physical laws. Finally, we want to study the importance of terminal velocity and Stokes' law.
My name is Maverick. I will explain about methodology of Stokes' law. Firstly, Stokes' law is a proposition that related the drag force experienced by a falling sphere. So basically, this experiment is by using a falling ball's viscometer that can determine the sphere terminal velocity. Stokes' law will be verified by the calculation drag force experience approximates that describe terminal velocity. We use a sonar range detector to track the movement of the falling coffee filters. This is for the second experiment to determine the terminal velocity. The detector measure the position of the object as function of time, which we calculate velocity and acceleration. By repeating this procedure, determine the dependence of the drag force on the velocities and the size of falling object. Besides of this reason, this will make the value of the experiment much more better and less error by repeating this experiment.
Hi, my name is Wan. We have come up of our result of our project with the Stokes' law. We have the formula of F equal to 6 pi r mu v, which is mu is the viscosity of the fluid and v is the terminal velocity. For the terminal velocity, we have come up with the formula to calculate the terminal velocity, which is v equal to square root 2w over cd ra. And then we also have come up with this graph for the terminal velocity. Next, for the discussion, with the Stokes' law formula, which is F equal to 6 pi r mu v, we can calculate the drag force using that formula. So the assumption that Stokes' law makes is the object must be in sphere and the fluid must be laminar. So for the terminal velocity is the highest velocity of object as it falls. So as you can see in the graph, the highest velocity is the terminal velocity. So it cannot reach up than the terminal velocity. When it reach the terminal velocity, the velocity is constant. So the acceleration is 0. So that's all.
So as a conclusion, terminal velocity is the constant speed that freely falling object eventually reaches when the resistance and of the medium through which it is falling prevents further acceleration. And Stokes' law is a formula for determining the rate of sedimentation, which given Fd equals to 6 pi mu Rv. So for the recommendation part, as this is when we're talking about force, so for the recommendation part, it is better if we do the every single experiment without the without existing of other source of force, such as force of friction. And bear in mind that Stokes' law only exert on the small particle object. Thank you.